Hi, and welcome to Chapter 10. In Chapter 10, we're going to introduce a concept called inheritance. Inheritance is going to involve the concept of being able to use code reuse and using different classes that relate to others. Let's get started. So first, let's talk about what is inheritance. Inheritance is similar in coding as it is in real life. When we talk about things that you inherit from your parents or your parents inherited from their parents, we're talking about traits or attributes that you may have inherited. Your ears, your eyes, your smiles, your dimples, things that you inherited. Maybe some personality traits, maybe some things that you do. Same thing happens in code when we use inheritance in code. It enables a class to inherit or acquire behaviors and attributes of another class. Now, you can acquire all of the attributes and behaviors, and you can make a few of your own. So, as you start as a person, you've inherited everything from your parents, but the environment or the situation you live in could make things, obviously, you're never going to be your parents. You're going to be different, and you're a combination. In the situation of code and programming, you only inherit from one parent. So, we have this relationship between classes where you have a base class, which will be a parent class or a superclass, and a derived class or the child class or the subclass. And I will intentionally refer to those different versions as we go through the lecture. Parent to child, inherited or derived class from a base class, and superclass and subclass. So these are the different types of things that we can do, and I want to make sure you understand the terms so that when I use them, you don't get surprised. The point of this is so that you can inherit code. You can inherit the code data fields and the methods that come from your parent class so you don't have to write them again. A lot of times in object-oriented programming, we talk about being able to use code reuse through inheritance, and inheritance is a big point of any type of object-oriented language. What we do in this case is we can have one kind of generic base class, and then we can build multiple classes therein. So if I had an animal class, I could have dogs as a subclass. I could have cats as a subclass. I could have birds as a subclass. And these are different things. They all are animals, or we could have mammals and then go down from there. We could do things like that. But if we all have animals, they all have certain things. What is their name? Where do they live? On land, in the air, in the water, things like this. And then each of the individual classes, the subclasses, can have different attributes that are associated with them. Do they have fur? Things like this. Can they be used as a pet? How many legs do they have? These are different attributes that you can assign to your subclasses, but they can all use the same attributes from the superclass as given. You're going to see how this is going to work with our party planning. Inheritance is only one way. The same way that you don't give traits to your parents, base or derived classes cannot give traits back to the base class. The base class does not change. It stays the same, and it moves on, and it has derived classes that are derived from it. We've discussed the different names of base classes and derived classes. Let's talk about inheritance versus containment. So inheritance generally uses the phrase is a. A dog or a animal is a dog, is a animal, is a type of weapon, something like that. Whereas containment has a. So when we do containment, that's referring specifically to having code that has an attribute that you want, or that has a method, something like that. These are things that are contained within your class as opposed to inherited from a parent class. With composition versus aggregation, these are also two very important terms, and recognizing the difference between the two is important. So composition is a relationship in which a class contains one or more members of another class. The members can't exist without the other class. If we had students in a school, if we don't have the school, the students can't exist. They could still be people, but they are not students at this point. So composition means that a school is composed of multiple students. Students cannot exist without the existence of the school. Aggregation is relationships where the class and its members could exist without the class. So if I have my specific course, CSCI 111, and you could be a part of my course, but you could also be a part of any other course, and if my course didn't exist, you'd still exist. In that case, we have aggregation. My course, while made up of students, those students would still exist if my course did not exist. Composition, you are composed of, the internal items do not exist without you, versus aggregation, I have items in here that can be used in other situations as well. They are not dependent upon my existence to exist themselves. By the way, quick little note, when you're writing your code, you can use the instance of method to find out what your class type is. This is really, really useful if you're going to go in and find out, is it of type animal or is it of type dog? So you can use the instance of. If my employee is an instance of the employee class, that can be a true thing that will tell you, does it work? Assuming you have the intention of continuing on in programming, you're probably going to learn about UMLs. UMLs stand for Unified Modeling Language, and it is simply a way of describing your object-oriented code. If you ever go into databases, this is important there as well because we use UML diagrams in databases. Yes, good programmers actually do this. This is documentation. You want to actually do this. Of course, you are welcome. I'll probably mark you down, but you are welcome to go through and design your class without UMLing it, without actually describing it and documenting what are the objects, what are the methods, what are the data fields, are they public, are they private, what are the resulting values. When you use a UML diagram, or in this case, just a box with data inside of it, you are going to list out your class name, obviously, the data fields in it, whether they are public or private. We use a negative or a positive to refer to public or private, what data field they are, and what methods we have. So again, methods are also public or private. So you can have private methods, public methods with positive or negative. And then what data field do they return, if they do? And what data fields do they take? So you would have kind of the header information from all of your methods. Documenting this is awesome when you actually do code because you may come back and if you don't have any documentation to describe it, you may not understand what you did. Also, you may not always want to go back and look at your class description. If you could have a documentation, a piece of paper or a document on your computer that describes all of your classes and all of the methods therein, you don't have to go back and reference them. Before IntelliSense, you would have to make sure that the spelling was exactly perfect, obviously, for all of your methods. With IntelliSense, it fills in a lot of those for you. So if you spelled something wrong, you could still write your code using the wrong spelling throughout the whole thing because you use IntelliSense to fill in, to automatically enter in that information. It's really important with inheritance, we use arrows to show objects that inherit from other objects. In this case, we have an employee and then an employee who has a territory associated. This way, we're able to describe the territory of the subclass and use an arrow to describe that it inherited. You only need to list your new data fields in your inherited class. So when you look at your actual code, every single line that's in your UML should be in the actual code, which means derived classes should be smaller or at least more contained than the base class that they inherited from. Do not repeat items that came from your base class. Those are in your base class. They're already documented there. They don't need to be documented secondarily in your derived class. The syntax for using a derived class or a child class with a parent class uses the word extends with an S. So in this situation, we have an employee with territory, and he is a child class of the employee class. So he extends his parent, the employee class. The keyword is extends with an S. The new class automatically receives all of the data and non-private methods. If they're private methods, they stay inside the parent class. But if they're non-private methods and all of the data fields, they come across automatically. In our employee class, if we had built that, we would have an ID and a salary, whereas our new employee class with the employee with territory, he also has a territory. So we need to have a new data field for the derived class and getters and setters. The getters and setters from the base class we get automatically, so we don't have to rewrite those getters and setters. The example here lists out the actual employee with territory as it is written to extend. All he needs is his territory and his getter and setter for territory, because the ID and salary came from his parent. At this point, we're going to go ahead and walk over to some code. We're going to be doing a party with a dinner party. So the party is going to be our base class, and the dinner party is going to be our subclass, derived class, child class. And then we're going to obviously do a use party test demo page or a file that we're going to use to show those. So let's go look at some code. The first project that we're going to do in Chapter 10 is going to be demonstrating how inheritance works. So I'm going to come over to my code, and I'm going to do the You Do It project on pages 474, 475. Obviously, I'm going to need a file. So I'm going to make a party class. And in this party class, I'm working as a party planner, and I have a basic party, and then I have a dinner party. And dinner parties are a little different than base parties in that they have food involved. So regular party, there's no food. This kind of party there is. So we're going to start with our base class of a party and get him built up. So he is going to have some things associated with him, his number of guests. So we're going to write number of guests, and he's going to be an integer. And of course, we're going to have getters and setters. So we're going to make our public int get guests. And we're going to make our setter. Okay, getters and setters. Getters and setters are great. Last, we're going to go ahead and make a display invitation. So this is kind of like my display method. Public void, and he is a display invitation. And he's just going to do a printout. Okay, base class, kind of boring, doesn't have much associated with him yet. He is our base class. So we're going to go ahead and save him. Let's make our use party method. And at this point, he's probably mad because I haven't added the class path yet. Let's go ahead and add folder to the class path, make him a little happier there. And we're going to go ahead and do our use invitation. So let's make our new file. And we're going to make our use party.java file. All right. We're going to use him. We're going to do our main. And then inside of our main, we're going to go ahead and do a scanner to ask the user how many guests are in my party. Make a couple helper variables that we're going to need to use. We're going to make a type of party. My party. We're going to call it a party. And set him equal to a new party. Remember, we have that default constructor. You notice we didn't write one when we wrote our party method originally over here. We're going to talk about constructors in one of the You Do It projects. Okay, let's add our scanner. Okay, so our scanner's been added there. Let's go ahead and use the keyboard to let the user know or tell us how many guests. So I'm going to do a system out. How many guests at the party? Because we're doing a party planner, so you should know how many guests. We're going to do guests equals input dot next int. Now we have the amount of guests. So I can set the amount of guests using my setter for my party. So I'm going to do a party set guests, and we're going to put guests in there. Okay, now that that's set, I should be able to say my print out. And then before the end, I'm going to go ahead and do my display. Okay, now that we have the display, I can go ahead and run my code. Let's don't forget to put her in .close. Make that a little happier. And we'll go ahead and run our use party and see how that works. Always good to test. How many guests are at the party? We're going to say 10. And we're going to say the party has 10 guests. Please come to my party. Pretty basic concept for a party with a class, and that should make pretty much sense. Nothing here is brand new to you now as far as inheritance. Okay, now we're going to build our subclass. So we are going to open a new file and do our subclass for our party. So our subclass is going to be called Dinner Party. And he is going to extend inherit from party. By saying extend, with an S, excuse me, extends, because he's a verb. So he extends party, which means he gets all of the things from party that party had originally. So he now has a guests data field, he has a get and a setter for guests, and he has a display invitation. Which means all I need to do separate for this guy is what are the things that are different between the two. I don't need to know the guests because that's handled by his parent. I just need to know what is the dinner choice. So we're going to do an int, private int, dinner choice. All right, from our dinner choice, we're going to use getters and setters because we do need getters and setters for that. So we're going to make it public int get dinner choice. Return this dot dinner choice, and we'll make him a setter. Public void set. And we're going to set this dot dinner choice equal to D. Okay, getters and setters. I don't need anything else for him. He already has a display invitation. He already has everything he needs except the dinner choice. So he has his dinner choice stuff. So we have, let's go ahead and make that a little smaller. So we have our party. This is our base class. Here is our subclass or our derived class, our child class, and back to our use party over here. And according to the you do it, they have you do a secondary main method. So a secondary file. I'm actually going to use the same file because I don't see any reason why not. At this point, we are going to just modify this kind of party to make it a dinner party. So we're going to make him a new dinner party here. And we're going to say how many guests are at the party. Still using a party and setting the amount of guests. And then we're going to have a dinner choice. And for our dinner choice, we're going to ask the user specifically enter the menu option. And then, of course, we always need to tell the user what the options are. So 1 for chicken and 2 for beef. Why anybody would not have beef at a party is just wrong. Okay. So then we're going to get our dinner choice. It's going to be equal to our input next int. So we can get that information from your from your dinner choice. Now, the party has how many guests? We have the amount of guests. The next is going to be what will be served. So we're going to do a system out. So we're going to print out what is going to be served. So menu option, and we're going to say which option was it? Plus a party, get menu or get dinner choice. And you'll notice here that both get dinner choice and get guests are available because we can pick either of them. So that'll print out whatever menu choice, either 1 or 2. And you can see it'll pop up and say how many guests are at the party. We'll say 15. And enter the menu option. We'll say 2 for beef. And it will say, oh, we forgot to set it. A party dot set dinner choice. And we're going to use D. That's why it was mad. Dinner choice. Okay. So we're setting the value. This is the debugging part. Always good to do that because it came back as 0, so we knew that we had never set it. Let's try it one more time. I'm going to guess the party 15. Dinner choice is 2. The party will have 15 guests, and the menu option will be served. So we can get all of the information that we need from our party class, and then the new things for our dinner class by whatever it needs. By being able to do that, we can reuse some of our code and be able to keep these two things together by making it so you just have to make a really, I mean, you can see how small this class is. We have a getter and a setter and a variable, and that's all that's in our extended class. We used the method from our SuperClass to display our invitation, but maybe we want to make a different invitation for our dinner class. But we still want to call it display invitation because that's what it does. And we don't want people to get confused as to what they're printing out. So we can do something called overriding a SuperClass method. We are going to use the @override keyword, and we are going to use the exact same header information from our SuperClass, just the code on the inside is going to be different. This is where your child decides he wants to go off and do something different. So even though you have a method for doing things, your child comes up with a different method. In this case, the child class or the subclass is going to have a different method implementation, but it's going to be the same name. It's going to be the same method header. Therefore, if you have a party, then in this case, and you want it to be a dinner party, the dinner party methods for display invitation are going to be different than the party invitations because they have been overridden with the child's version. We call this polymorphism, or in the Latin breakdown of poly, many, forms as morph. So same words, different action. They do different things. We have different forms. Polymorphism, again, is a big object-oriented concept. Being able to recognize that we can do that, have the same method name doing two different things. Be sure that you use the @override tag, so you need to make sure that you use that so that it knows that it's a overridden method, not a new method of its own. And be sure you use the exact same method name and header information. Don't add in a parameter at this point or change it from public to private or change the return value. It needs to be exactly the same. At this point, we're going to go ahead and come back to our party classes, and we are going to override our display invitation. So overriding an invitation, as we just talked about, is going to involve writing a new method for display invitation that is going to be used only when it's a dinner party. So over in my dinner party, I'm going to add in a override with the keyword override, and then the same header that we would have originally in our base class. So void display invitation. So it's the exact same header here. So you can see line 13 is going to be exactly the same as line 12 up here, except that it has the word override above it. That means it's going to override its parents and it's going to make its own method. In this case, we're going to just take this same text and change it to say, please come to my dinner party, as opposed to my party. When I come back over here to my use party, how many guests are at the party? We're going to go 15, 2 for beef. And you can say, because it is a dinner party object, it's going to say, please come to my party. At this point, we're going to go ahead and create some constructors. We haven't done constructors with our party class because we wanted to get to this slide so we could explain how to use a constructor with inheritance. When you make a regular constructor, you can add parameters. We've done this before, and allow you to preset some of those data fields with your constructor. Default values and or additional values that you can add with parameters. When you use a subclass, you call the constructor for both the superclass and the subclass. And by doing this, we use the word superclass, so we use the word super, and it's a method. Just like a constructor with, if we had done this with open and close parentheses, in this case it's super. If there is no parameters in your super constructor, you can just do super, open and close parentheses. The important part about the default constructor or the constructor for your superclass is it must be the first line in your subclass constructor. You have to make the object with the super constructor first, and then you can add additional things. In our situation, we are going to make a constructor for our dinner party, or for our party, that is going to take how many guests, because we don't want to have to use the setter, we want to put it in a constructor. Then we are going to use that for our dinner party to set the number of guests and set the dinner choice afterward. Remember, the super entry needs to go first before you do any additional information. You can use the super with arguments the same way you would just using a constructor, and then continue on. Remember that super has to go first, and you can have a constructor that just has one line that's called super with an open and close parenthesis, and that is fine, but you must have a constructor that goes along with it. The last thing that we're going to do in this chapter with code is we're going to be dealing with our constructors. You notice I didn't add a constructor up here. The reason why is because we are going to be using the constructor part in this lesson to show you how to do that. So up at the top of our base class. Now in the book, what it wants to do for this is actually build two new classes, party with constructor and dinner party with constructor. I'm just going to modify my two previous methods because I think it just makes things a little bit easier. So we have our party here. I'm going to go ahead and add my constructor. So when I add my constructor here, I'm going to make my public party. And I'm just going to put in a printout so that you know that the constructor was made. Okay, I can go ahead and do another public party with an int guess. Let's make it just a G. And do this dot guess equals G. And include in creating a party with parameter. You'll notice that I like to put in, actually the book does too, I like to add in comments in the form of printout statements. I may remove those, obviously, if I was running this actual code. But in this case, it makes things a little bit easier for me. Down at my subclass. Again, he doesn't have a constructor yet, so let's go ahead and give him one. And we're going to use the ability of a constructor to use that super method, or the super that we talked about prior to this. So we are going to do a public dinner party, and we are just going to call super, open and close parentheses. So his is going to call the creating a party. Let's add in inside constructor for dinner party. Now, super always has to be the first method that you call in a constructor like this. So you always have to start with a super. You can't put stuff and then put the super together. We're also going to make a public dinner party that takes an int guess and an int dinner choice. In this case, we are going to call our super, whoops, with our guests. And finally, we will add our this dinner choice equal to dinner choice. So the super guest is going to call this constructor up here to set its constructor. And you can see after the super guest, we could go ahead and do another system out inside dinner constructor with parameters. Okay, all of our code looks good, no complaints there. Let's go ahead and change a little bit here. Instead of setting it here or setting it here, I'm going to get my two pieces of information, and then I'm going to set my party equal to a new party with a constructor. So here I'm going to do a party dot party equals new dinner party. And you can see the options that I had here. I can either do the one with the guests and the dinner choice, which is the one I'm going to do. I'm going to take guests and dinner choice, put those in there directly. Okay. Let's run and see what happens. So instead of using the setters, I added using the constructor. So I made my party here. It's really important that I did not use any party methods prior to this. Otherwise, obviously, if I made it down here, nobody would be able to see it. How many guests are at the party? 15. What's the menu? Beef. And you can see that we still had everything work out just fine. The party has 15 guests, menu 2. In here, you can see which constructors were called. Creating a party with parameter was called first. So if we came over here, creating a party with parameter, this one was called first. We called this method. So we took this method, we went into super, we went in here. This method was called first, creating a party with parameter. Next, this method, or this print statement was printed here. So you can see what happened over here when I had new dinner party with guests, it immediately fell into this method, the one that was the dinner party with the guests. Then it ran the super method up here to call its constructor with a variable, and then finished out its own by setting its dinner choice. Sometimes in inheritance, you want to use your superclass's methods. So if I have a method in my superclass and I want to use it in my subclass, I can do that. In the example of our party, I could make a display dinner as opposed to a display invitation. And the invitation for my dinner party would actually call display dinner and then call the display invitation. So I didn't have to have that code separated out. Again, it's always useful to reuse your code. If you are accessing the SuperClass constructor, remember the super must always come first. Otherwise, the methods can be in any order. You can have SuperClass methods below or above any base class methods or derived class methods, and that's fine. There's no problem with that. You just use the keyword super the same way you would with the keyword this. So we use the keyword this to reference this class's methods. Super references the superclass's method. So the keyword super is done specifically with that. If the method is overridden, super.myMethod is the superclass and this.myMethod is the subclass. Otherwise, super, my method, this, my method, and my method all essentially mean the same thing. So the point of using super here as opposed to display invitation is because the method display invitation has been overridden. If the method is overridden, you have to differentiate. Do I want my child's version of it or do I want the parent version? And in this case, you want to use the word this or super to make sure you understand which version of that method do you want to use. In class construction, we're really big on hiding information from the outside world that doesn't need to be known. Private. So we make data fields private and use getters and setters to access them so that we can control the data that is being released. If they were declared as public, you could access them directly. You could literally say my party dot guests and be able to reference specifically. But if we make guests private, you have to go through a setter and getter. We like to use the setters and getters because we want to make sure that we can control how the data is being retrieved and used. We can do validation at this point or verification. This goes for subclasses as well. Subclasses cannot directly access their superclass's private data fields. They can access the getters and setters though, because those are public. So your subclasses cannot directly say set the guest's number or anything like that if the guest is a private data field. Way to get around this. If your data fields are protected instead of private. Protected means that I can see your data fields even if they're protected as opposed to public, but people outside of the subclasses can't. So as your children, I can see what's going on with the parent information. Outside world cannot. So protected opens things up to subclasses to make things more available to them. Good programming still encourages you to keep things private and letting the subclasses use the getters and setters. It's kind of like you have your purse or your wallet in your house and your kids could theoretically go in and take money out of it. Obviously, someone can't break into the house and take the money out of it. I mean, it could, but normal people from the outside couldn't. But do you really want them to do that? And wouldn't it be better if they asked you and they had to go through a method to be able to get that information rather than just breaking into your wallet? So, good programming still encourages you to keep your data fields private. Make your subclasses use the getters and setters. That's why they're there. We can choose to make a subclass unable to override a method. By doing that, we can make them static or final. So let's start with our static methods. If you want the original method, if you want to hide the original method, don't use override. If you want to, you can declare a new static method with the same name, and you can reference the static method using the class name. So if I had my party, I could do party.myMethod in this case, and then I could do, if it's a dinner party, I could do dinnerparty.myMethod. This doesn't override anything, but it does make your methods static. Remember, static methods do not need to have an instantiation of the object. They reference the class name. So it's important to remember what static methods are. That way you can access either of them, either the superclass or the subclass method, by just making them static. Final methods can never be changed. So if I make a final method, so I call it final using the keyword final, the compiler will not allow you to make a subclass overwritten version of that. You cannot override a final method. They can't be changed because they're final. What the compiler actually does with a final method is when it compiles your code, it actually inlines the code. So it takes the code from your final method and puts it right into the code in that location, which makes it much more faster and efficient, which is great. Final classes cannot be extended at all. So if I want to make my class final, remember we talked about at a class header information, you have a public class and then whatever it is. In this case, you can make it a final class that can never be a parent. Nobody can extend it. It cannot be a superclass to a subclass. These are different ways that you can make a class not be able to be overwritten or extended. You can ensure that your method in your class cannot be changed or overwritten by inheritance. That's important because sometimes you want to make sure nobody can take your class and alter it. You want to make sure that there are no other versions out there of children extending from the parent class. Couple of reminders with inheritance. We are going to do another chapter on advanced inheritance. So if you're not really getting it or if you're struggling, it's okay. There's more coming. First off, the word instance of has absolutely no capital letters. It's not camel case. A lot of people put a capital O here and can't figure out why the syntax is wrong. It's not a capital O. It's instance of, all lowercase. Private superclass members are not available to subclasses. You have to make them protected if you want the subclass to see them. Remember to call the superclass constructor first. Remember that super with the open and close. If you don't use the default constructor, the default constructor will do it automatically, the one provided by the compiler. But if you make your own constructor, make sure you always call that super constructor first. You can't override final methods, and you cannot extend final classes. The word is extends, not extend, but use extend, not inherit. We talk about inheritance. The word is inheritance. The concept is inheritance. The key word to do it is extends. Hopefully this gave you a little bit of an introduction to inheritance. Inheritance is a very, very important concept when it comes to object-oriented programming, so I hope that you understood. Please come back next time and we'll talk about a little bit more inheritance and different ways that we can use it in a real-world situation. Have a great week.